In this video, we'll talk about a very important topic of where variable names are valid and where they aren't. This is called a variable scope. For example, if I run this program, this will call the function test, which sets x to be 3, and it prints x, so it printed 3. Let's try to print x outside the function. So here we go. We're going to run it again. It gives us an error. This says name x is not defined. What do you mean it's not defined? It's defined right here. X is 3. The reason it says this is that variables that are defined inside a function are valid only inside that function. So they're called local variables. This is outside any function. So variables defined here are in the global scope. So Python has a particular order where it looks for things. If you have a function test2 and it's trying to print y, the first place Python looks is see if there's a local variable defined. Do we have any place inside the function where we define y? No, we don't. So now it's not a local variable. It's going to look now and see if this defined globally. And yes, y was defined to be 11 before. So this y equals 11 is a global variable that's still accessible inside the function. But what happens if there are two variables defined differently? So let's say here's a variable z is 13 here, but inside the function we're defining a local variable z. Well, Python has a particular order that it looks for things. It tries to find a local variable. In this case, it can find it. So it found z is 8, and there we go, it prints 8. That's the very first line up there. But if it can't find a variable locally, then it will use the global variable. There's another one in between, and then finally there's a built-in scope, which is things that are available everywhere, like the word true or the function name print. Those are built-in. Those are variable. Those are everywhere. So here when we ran test3, it printed 8 inside the function. But outside the function, let's run that again. Here, we are not inside the function, so it's not using the local variable z. It's using the global one. So this one, outside the function, prints 13. So if there's duplicate, then the local variable takes precedence. If for some reason you want to actually change a global variable inside a function, you can do that if you actually tell Python that we're going to use a global variable. So now when you say z is equal to 8, it's not going to make a new global variable z. Since a new local variable z, it's going to use the global variable, and I need to define the global variable. I deleted that when I changed programs. Let's make it 76. It will actually use z. Let me actually print a couple things. Let me print z first, and then we'll run the program. Okay, so it printed z. Then it runs test4. Now z will be changed to 8. So if I print z again after this, you'll see that it actually changed from 76 to 8. It's typically not a good idea to use global variables. One of the benefits of having a function is that everything's, kind of a chunk encapsulated, and it would be kind of tricky to debug if every time you use a function, you have to try to remember, like, is this function everything? Or do you need to remember that it's reliant on some global variable? So as much as possible, try to avoid this. Even that one example where we accessed a global variable inside a function is probably not a good idea. So when you pass an argument into a function, it's creating a local variable. So here we have the number 21, and we're passing num into the variable, into the function as an argument, as a parameter. And so this parameter then will take, it's like in a local assignment, it's like saying w equals 21 here, and this is a local, w is a local variable now. So it'll print 21, which is a local variable. But if, once again, if I try to print w outside of the function, then this will give me an error. It won't be able to do that. So this is one reason why maybe we're wondering about this. Often we create different variable names than the ones outside of the function. So I'm passing the variable num here. This could be just as easily called num. You just have to know that that's a local version of num and is not the global version. But there is one case to pay attention to. If we define a list in the global scope, this list, when we pass it as an argument, you would think that this is making a new copy of a list. But I don't know if you remember from the list video, this list, LST, points to exactly the same place as my list. These are now just made synonyms, but if I change this list, LST list, I'm actually changing my list. So it looks like it's a local variable, but since it's a list, which is a mutable object, those changes will be made to the only copy of list that exists, which is outside the variable. It's available in the global scope. So this, if you want to pass a list, a copy of a list, then there are ways to pass just a copy. Like, for example, a slice makes a copy. This will pass a copy, and then this now list won't point to my list. It'll make a new copy. And then let's do this again. And if I run it, I ran it, and it just has 1, 2, 3. So inside the function now, inside the function, it just replaced 89 in its own local copy. So let's print LST to see what the local copy is. And the local copy has been changed, but the other one hasn't. So a slice, again, makes a copy. And there's other ways to do it, like you can use the copy list method.